Algebra I 10.11a, the division theorem, and proof. As we work with division of rational numbers and division of rational expressions, we use the division rule of multiplying by the reciprocal of the divisor, and we can prove this rule. So here's the division theorem. It says for any number a and any non-zero number b, so remember the denominator can't be a zero, right? Because we can't do that for a fraction. So if we have a over b, it's going to equal a times 1 over b. See? That's the reciprocal. If b is the denominator, we can write it as b over 1, can't we? So the reciprocal of it is its flipped around version as 1b. So we can multiply a times 1 over b, the reciprocal of the denominator, and these are going to equal each other, see? Think of it this way, like we had 10 over 5. That's going to equal 10 times 1/5, see? We'd multiply 10 times 1 and 1 times 5, and we get 10 over 5, see? So do you see how that works? All right, so let's check this out. To prove this rule, we'll use the definition of division. So a over b equals c, like 10 over 5 equals 2, right? If a over b equals c, if c times b equals a. So it's like 10 over 5 equals 2 if 2 times 5 equals 10. Yeah, that works, doesn't it? So remember, the division is the inverse of multiplication, and multiplication is the inverse operation of division, right? So to show that a times 1 over b equals the quotient a over b, we need to show that when b is multiplied by a times 1 over b, the result we're going to get is an a. So let's make a proof table listing our statements and reasons. We use proof tables in geometry to show logical thinking. So here's our proof table. You make a table that has statements on one side and reasons on the other, and you number them. So the first statement is next to the first reason, and the second one next to the second one, see? Third next to third, and fourth next to fourth. So the first thing we're going to do is look at our first statement. We're going to say that a times 1 over b times b equals a times 1 over b times b. See how we grouped it differently? So in this one, the a and the 1 over b are grouped together, and then we're going to multiply it by b on the outside. Now we move the parentheses to be around these because b is really b over 1, isn't it? So the associative property of multiplication says that we can do this, that we can group differently. So that's our reason, okay? This a times 1 over b times b equals a times 1, doesn't it? Because this is like a b over 1, so we got b over b. That's the definition of a reciprocal, okay? And a times 1 is a. That's the multiplicative identity property. You know, you multiply by 1 and keep the same identity. So now it equals a. And if we take this a times 1 over b times b, we can say that it equals a. See? Our reason is the transitive property of equality. And we talked about that earlier. That means for any real numbers, a, b, and c, if a is equal to b and b is equal to c, then a is equal to c. See? It's a transitive property. If these two are equal to each other, and this one and another one are equal to each other, then the first one and the third one have to be equal. Okay? That's transitive property. So therefore, by definition of division, a times 1 over b is equal to a over b. See? And actually, we could just do that. We could put the a over a 1, couldn't we? And then we'd have a times 1 over 1 times b. That would be a over b, wouldn't it? Multiplying by a reciprocal can help us divide rational expressions. Okay? So our next video, 10.11b, we're going to talk about the reciprocal theorem. All right? And if you want a link to any of my previous videos, they're going to be in the description of this video. And you can just click on them. We did a lot of really good algebra word problems, and my word problem playlist will even be in there. And we did the factor theorem before. We even did some acid mixtures and stuff like that. So if you want to click on any of those to help you out, they're just one click away. All right? Okay, let's talk about reciprocal theorem. I hope you're doing well, and I'll see you next video. Bye.